So in this tutorial I'm going to show you how to make a simulation of a contra-rotating propeller stress simulation. So let's go where we left off last time. Here are the results from last time. I made a mistake with the solver. I accidentally froze this solver, but this solver is also necessary for the simulation, so if you don't have this result, this might be the thing you did. That's what's wrong, what messed up the simulation. But so these are the things. Let's first start with mapping the thrust, with mapping the pressure from the fluid simulation, so that we don't forget it. Let's go to data mappers. Let's make an extra data mapper volume. Let's make target. Target is the stress, it's good, and the input is the absolute pressure from rotate. Okay, it's good. Then make another one. The target is the source is the rotate 2, and the target rotate 2 in the scalar field is again the absolute pressure. Yeah. Why is this on my screen? Okay, it's good. And the target is again the stress, of course. It's all set up right. Target here is stress. It's all the same. Yeah, it's the same. So let's map the data, and let's map the data. Oh, it's busy. Let's map it here. Okay. So if everything went alright, I can see the data in a scene. Make a scene. Regions, where's the scenes? Scenes. Okay, my scalar scene. I can see the pressure. You can see the pressure here. That's from the scalar scene. The parts is not. Which region is it? No, I don't want the rest. I want the stress region, so I can see it worked. Oh no. The stress region isn't yet. No, that can't work. Of course, the stress region isn't yet set up alright. But doesn't matter. So let's now make some changes to the propeller so we make a more realistic scenario. So I want to make a SPI input to mimic the real situation. So let's export this to step file, and let's say it's here, the front. Let's call it front, and I make a step file of it. And let's open it. Front step, yeah. Okay. Let's open it. Solid surfaces, convert to model. Okay, this is Autodesk Inventor. I prefer to work in this because I'm more familiar with this program than STAR CCM+, but normally you can also do these changes in STAR CCM+. I don't see why not. Okay. Let's make another sketch. These are not specific made dimensions, but just make something up. to mimic a more realistic scenario. Okay. So now we have a way of connecting our propeller, and we can also fix propeller on this surface, so it's more realistically than on the back, because you won't fix the propeller with your back with something like this. Okay, let's export it again to step file, front step. Yeah, front step is good. Okay, then let's import these propellers. Yep, and front STP, not a step with the STP, as from Inventor. And we can see it right here, and I will call it I hope it won't interfere with the merge command. No, normally it won't interfere. Stress, okay. Let's export these new geometry parts. Very fine. Stress 1. Okay. And then we can delete this, yeah. Edit. Maybe just to be safe, let's delete this. No, it won't interfere. It's no problem. Import cat. Let's first export this again, of course. Export. Aft propellers. Aft. Open. Let's go the aft. Okay. Let's do the same again. Let's do it all in one. Apply. Save, and then export of the SCP. Okay. Let's go to here, let's do import cat models. Front, aft STP. The IPT is the original Inventor file. STP step is what I imported in the SCP from Inventor. So you can see it here. Okay, update close. Okay, and let's export these also. Okay. Now we have two more realistic propellers. This one can go away. So stress 1, stress 2. Why did they update? Yeah, because of the... Yeah, that's normal. Wait. Okay. this of course also have to be updated, but first these two can be set to region stress. Okay, let's go to a stress region. It's on the same position. That's actually strange. Let's go to scenes, geometry scene. Why can't I see these two things? Wait, in the regions, boundaries, of course, I can do. Make a new boundary. Let's call it stress 1. Okay. And then where is stress 2? Is it placed correctly? Wait, what? Okay, it's placed correctly. Okay. Just to be sure. Yeah, no, it's correctly. Okay. Just delete this boundary. No problem. Delete these segments. New. No. Great. Transfer. Create segment. Surface segment. Create segment surface. Create segment surface. Create segment surface. So. They can be placed in the same region because they don't have a different rotation or something like that, so you don't need to make specified regions. No, I will just use the same surface for loading constraints because I don't split it as surfaces yet, because it's not possible as long as you don't make your mesh, but that will be done soon. These two are the inputs. Okay. Right. I think I can yet split the surface. Maybe. Oh, well, I can already split it. Okay, that's easier. So I have to hit this or this surface. So let's look at this surface. It's of course not that. It's already this. Okay. I will call it constraint. Okay, great. Close. It's default, and then this is the constraint line. I'll take stress 2. Split by patch. I'll also select this one. Oh no, I will have this one because the rotate is in another direction. So okay, close. Okay. So now I can choose the right part. So this is not a load, but this is a constraint. It's also a constraint. And I can use the constraint 2. Okay. This is the constraint, and it's the constraint 1. This is stress 1. Okay. This is stress 2. That's good. So loads. It's not a force. It's a pressure. It's continuous. It's a field function, and it's the mapped. So this is load 1. So it's mapped 1. Where is it? Where is it? Mapped. Mapped vertex upset pressure. Wait. What's of the two? No, I think it's all in there. I think it won't matter. Field function. Also the mapped vertex absolute pressure. Okay. So the regions are set up alright. You can see the loads, both loads. You can see the constraints are more realistically. And last time, man. Why can't I just delete it? Yeah, it won't interfere because there is no parts with it. So let's execute the mesh. Let's save it first. And let's execute the mesh. I will come back to you when the mesh is finished. So the mesh is complete. You can see the mesh right here. So it's looking good. You can see the fluids simulation part is a little bit different than the structural simulation. You can see the changes in our inventor files from our inventor file. Now let's go to Continua and activate our structure simulation, and then go to our solvers, our name here, and then the study, the implicit study has to be turned off, rigid motion turned off, solid stress turned on, fluid capture turned on, partitioning turned off, wall distance turned off, coupled implicit turned freeze flow. K omega turn off, and gamma transition turn off. Okay, and now this one is active, this is not active, so we can run the simulation. Yeah, I accidentally launched the simulation after the mesh was complete, so there's a spike because in the start you always have a little bit of spiking before it converges, but the data mapping was already on the converging part, so it doesn't matter that much. So that's why there is a spike in residuals right here. So our stress simulation is running, and I will come back when it's ready. So now the results are ready. You can see quite well the influence from changing it constraint right here to right here. Now there is some stress maximization on it here, and you can see also the stress is also here. Yeah, these are the results from a contra-rotating stress simulation. The stress on the second propeller is less than on the first propeller, and yeah, that's everything for today. Let's check one thing first, and let's go to see that the last step wasn't included. The pressure, absolute pressure mapped vertex absolute pressure, so it is 0.1 megapascals maximum, see it right here, and then really low here, and then you can go to see it's the same as the absolute pressure on the rotate region. Normally it won't be the same because I've mapped a different step, but let's see. See, this is a different step. Here the pressure is higher, and that's because I mapped these two steps, and this is a step right now. You can also see that the thrust is here different, and the torque is also different. You can see that also going back, map pressure. So that's it for today. I will see you next time, and I will stop the recording right here.